Let's talk about this bomb. First thing I want to point out is that I have actually made prefabs of everything in my scene. I even have a bullet. I was playing around with actually having this eyeball shoot out a bullet, but I decided that I'm going to check out this laser beam thing for now, but maybe I'll add in a projectile later, so I'm going to keep this prefab from my other project, the previous section, handy, just in case I want some kind of a projectile that's already made. However, our most interesting one to look at right now is this bomb itself. I'm going to drag one into my scene view just for a sec to talk about what it is that we're seeing here and to show you about this weird kind of pink glowiness to it. This pink comes because I've actually removed all the materials from this object. I set my physics material to none, whereas before it did have a natural color associated with it. When I first created it, it was like a normal sphere that had a material on this renderer. Sorry, I think I was looking at the wrong spot. Is my renderer. The element for my material is 0, and here is the default material. I took away the material because, until I did the wrong thing there, I want to create all of my material information through a script for this object. That's kind of my goal here. So this bomb starts at a fairly small size. It has our normal components rendered only with the material removed, a collider, a rigid body, and now I have this bomb manager script that I will talk you through next. In this bomb manager script, I have code for logic and code for the consequent explosion. The logic, I'm going to be actually not counting frames here. That's a relic from a previous idea I was going to show you, but something that a lot of you are very much aware of, keeping track of frames with a counter. Instead, we're going to do something a little bit more interesting with a timer built into Unity. And then for our explosion, of course, I'm using a particle system to show the explosion animated particle effect, but I also have some information about the physics effects I have on the objects around it through the radius and the power. Okay, so let's see how this all works out here. When I start up the script, I want to actually log a start time as a float number based off of this call to the class time.time. This is a field that holds the information about how long in seconds time has passed since I started the game. So whenever the script is created, it's just going to log how many seconds have passed. Maybe it gets created immediately, so that would be 0. Maybe it gets created 10 seconds in that case start time would be 10. But it's going to log in a precise value of the time that then I can actually call again later on to get an update of the new amount of time that's passed. And if I compare my start time with the new time later on, well, I have a way of determining how long something's been going on, nice and directly, without actually doing a counter myself. It's frame rate independent. It's based off this universal time. Let's see how this works. First thing I want to show you in our update method is that I can actually change the scaling of my object. And what I'm doing here is I'm adding to my object's local scale, meaning that it's basically referring to its own subjective scale values. I'm adding every update a new vector 3 that on all 3 dimensions is being scaled in the same way. This is a sphere, and I want it to remain a sphere, so everything has to grow at the same rate. And so I'm attaching a growth scalar to this, and you'll notice that my growth scalar value is very, very small. That's because every frame happens pretty often, and the bomb gets way too big if this value isn't very tiny. So there's my growth scalar in action, and you can play around with this at higher settings just to see how absurd it gets very quickly. Next is the code for the color changes and the time delays. Let's take a quick look at the logic of the time. If the current time that I'm examining when it's updating is less than or equal to the start time I gathered when the script was generated plus my explosion delay, some value that I'm inputting, I think I put in 1 for now, which is 1 second, how long I want each kind of state of my bomb to take to reach. If I made this 5, we'll see some obvious changes to how this bomb works. There's a bomb I added to the world, and notice that before it changed color really quickly, and now it's going to get very big because it takes 5 seconds to go through each different state. And this is kind of fun in a way, but it's pretty absurdly big, and we'll just stay really close to it, just see in a sec what happens when it reaches its endpoint. there's a way too small an explosion for its size now, but you get the idea that if we change my prefab bomb, this value too much, then, oh, I clicked on my bullet, not my bomb. Oops. Then it grows too big. I think I clicked on the one that's in the world itself. I should really be working out of my prefab. Let's go back to it and take a look at this here. Back into the script. So this explosion delay, I have 2 times it, 3 times it, 4, and 5 times it for the 5 different states that each are equally spaced out, but definitely unique. And so if my current time reaches this next tier, or the tier afterwards, you'll notice that it starts black, then goes to gray, yellow, red, and finally it explodes. Let me tell you really quick about how we're changing the material. It's really simple. We're gathering the component of our renderer. So get component of our renderer that's responsible for having the color assigned to it. And we're going to look at the material applied to the renderer and its color and set it to a new color, of which we have a big list of. You could create your own RGB values in here, lots of different options. I'm just going with some generic base colors, no problem. And the different tiers of it should be pretty easy to follow with our if chain statement. But here at the end, we have our explosion happen. And here's where we get to see something brand new, a for each loop. I think this is the first loop that we've seen happening in our course, and we'll see it working really beautifully here to create some cool functionality. So what I'm going to be doing is getting the position of the explosion, which I'm going to set to my current position, or the current position of the bomb. And next, I'm going to get an array of colliders. How I'm going to get this array, or what objects are going to fill this collider array? Well, the physics class has functionality called overlap sphere. And what this is going to do is it's going to create an invisible sphere at this position with this radius. And remember, we defined the radius up here that I can tweak to make the bomb have a larger or smaller effect range. So I'm generating a physics object that creates an invisible sphere, and anything that is inside of this sphere is going to be added to my array. And it's particularly going to add the colliders of those objects. So I'm getting a big list of all of the object colliders. So let's take a look at our game here for a sec and think about what it is that's happening. When I'm coming over here and I'm dropping this bomb off, there's actually, when it explodes, an invisible sphere that's generated that every single thing inside of it, it gets access to its collider component. And then I use my for each loop. For each collider that I'm calling hit in my colliders array. I'll say that one more time. For each object of type collider that we're calling hit here in my colliders array, so it's going to loop through every single thing found in this array, I'm going to get the rigid body of that thing that was hit. So I'm getting the rigid body component and assigning it to a rigid body. Now, what happens if something that the bomb hits doesn't have a rigid body? For example, one of the walls. Well, we have this condition here. If the rigid body is not equal null. So, of course, if it touched a wall, the wall doesn't have a rigid body, so it's going to skip over doing this functionality, which is what we want. However, if there is a rigid body found, we can add explosion force to that rigid body. Remember, we're looping through all of them. So all at once, in very fast succession at least, we're adding an explosion force to all of them. With this amount of power that we defined above, at the explosion position that we gathered from our current bomb place, with the radius that we define, so it's going to apply the explosion to everything that was found in that collision radius. And then there's this extra setting, this last value, I made a little comment about it here. The last value is an upwards modifier that adds vertical force for a cool effect. Otherwise, everything in the scene is just going to have the directionality of where it is relative to our explosion. So if I set this down to 0 and reset my scene, when it loads here in a sec, what I should be seeing is that there's none of that cool upwards explodey effect. We'll just poop this out here. And when this explodes, it's going to throw things sideways, maybe a little bit up as they bump, But there's a lot of force missing from this interaction because it only has the kind of sideways effect as it was to the side of the explosion. So maybe if I turn up the overall force, these would still fly sideways, but that upwards kind of extra oomph that it gets comes from Theer. I think I said the 300. I think that had a cool look to me. So I loop through and I apply a force to all of the objects. Awesome. Now, after all these forces have been sent, now it's still in the same method call. So in actual, the way the logic is being processed, none of the things have moved yet, but they've had force added to them. In the next update of the frame, they're going to be now moving based off of the new forces from the physics system. Something to think about here is that since we're triggering some physics interactions, we should probably be using fixed update. That would be the better choice. I didn't originally because I was only dealing with time things, but afterwards I added this explosion, and now that I'm dealing with physics, rigid bodies, I should actually probably go and update it. So let's do that really quick. What happens after all of the momentums and forces are added? Well, I'm going to actually trigger my particle system explosion at this point, that little fire explodey effect. I'm going to play it, and then I'm going to destroy this game object, the bomb, so that all that's left is the explodey effect and the forces that are causing things to fly. Let me show you one more time here, just so that we see how this all comes together. When I press the space bar, instantiates a bomb that goes through the loops of the different states as it grows slowly over time, and then it applies the forces to all the colliders in that invisible sphere that it generates. And then I have a nice path forward to the next part of the level. So I have a bit of a semi-puzzle-ish state here, or something that I can toy around with in this very early prototype design of this experience. All right, so this is a pretty simple experience so far. In the next section, we are going to learn about ray casting, and we're going to be adding in the ability to affect the world around us by shooting out invisible rays that get us information, and we'll see more about it then.